let's start with experiment number 2. This is Shobhit Sahu. ECE 37 17EC01037 is my roll number. The aim is to write Arduino programs for studying the performance of moving average filter, first order difference filter, and 3-point central difference filter. We need to analyze the performance of the filters by live recording the PPG signal using a PPG sensor and also on two pre-recorded ECG signals. And this is the definition of moving average filtering of PPG signal. We see that it is a simple low pass filter, takes some samples of input and takes the mean of those to produce single output. As the length of the filter increases, smoothness increases. This thing that you see is the simple time domain equation, and below it y of z, and then h of z is the transfer function. Similarly, we see the first order filtering of PPG signal, y of n is equal to x of n minus 1 is the simple time domain equation, and h of z equal to z minus 1 by z is the transfer function. Then we see central point difference filtering, y of n is equal to x of n minus 2, y of z is equal to 1 minus z to the power minus 2 into x of z, h of z is equal to y of z by x of z, that is z minus 1 into z plus 1 by z square. The main difference between the first and second order low pass filter is that the stop band roll off will be twice the first order filters at 40 decibel per decade. This is the major difference that you're going to see. Let's start with the code. The first code should be here. This is the analog input pin A0. Input for 500 samples are taken, and this is the block that does the moving average filtering over here. L, we've set the window size to 10, and this is the outputs we'll be obtaining. I'll show you the output ones. This is the output we'll be obtaining on applying moving average filtering. You can see this is the original PPG signal, and above is the output waveform being made out, and that is how we see the output, and that is how this is the output we have obtained on the Arduino platform. Let's go to the second code for for the first order derivative filter. This is the first order derivative filter. This statement you can see over here, y of I is equal to input of I minus input of I minus 1. This is the difference that we are calculating for every consecutive signal, and that is how the output is being plotted out. I'll show you the waveform again over here. Above you see the PPG signal, and below is the output, and I guess you can figure out how the output is being so smoothly calculated. Let's go to the third figure. The third equation, or the third program we have done in the Arduino platform. We have again put A0 as the analog input pin. 500 samples input has been taken, 2 output arrays has been created. Same thing here, we don't need L equal to 10. You can choose to remove it, it is immaterial. And baud rate same at 9600. Y of I is equal to input of I minus input of I minus 2. This is the output we'll be calculating, and see, and the output is below 200. Like there are levels that have been differentiated so that you get to see the output waveforms, both the input and the output waveforms distinctively and more clearly. We'll see the waveforms as also. Okay, so you see this is the PPG signal and the output we are obtaining, which is completely done on the basis of the whole code on the Arduino platform itself. Now we'll go on to the two data that was given to us by our own faculty. The I've recorded the videos and I've made GIFs. As you can see, everything is over here. The two data, first is this is the first equation, and this is the first signal, EC signal that was given. This was the MA, this is the moving average filter. You can see the peaks coming up properly, and this was one of the codes. It's the code, you needn't do much about the code. All you need to do, I'll show you the changes in the MA filter. See, basically what you do is you've done over here, instead of this you can comment this line. You can go over here, float input 2000, because that is the number of samples, is equal to open close semicolon. Now I'll try to open up the file that has been sent to us. This is the CSV file that has been sent to us. I'll open up with the notepad. See, this is all the 2000 samples. Control A, Control C. Then all you need to do is just go over there and paste it. That is all you need to do. Your input is done. You can just remove this statement ahead and run the program, and that's all, and you'll get this waveform easily. This is for the first signal, that is 103. This is the DF, that is the first order derivative filter. It's the same process. All you need to do is, instead of taking the live input pin, you have to put up the global array and put up all the variables and all the values. And this is the second order derivative, or the central point difference derivative of the, in that case. And that is all you need to do. Same procedure again, just remove the live recording pins, like the pin diagram definition and all, and just put in the array and hit the run button. It's going to work completely fine. Apart from this, let's go to the second signal, GIFs that I've stored. Here is the MA filter for the other signal that has been given to us. Though disclaimer that all these signals are pre-recorded and these are not the live signals. You can see the difference in the peaks from the video that has been recorded, or the GIF recorded itself. This is the MA filter, this is the first order derivative, and this is the second order derivative. I'll repeat, this is the MA filter, this is the first order derivative, this is the second order derivative. I hope you got to learn a lot about live PPG signal and all, and we hope to continue the video in further sessions. Thank you.